Hello, everyone. My name is Javad, and I'm one of the members of the GeoHackathon 2022. We are very happy to have you all here. So today we have the 7th session of the Energy GeoHackathon 2022, which is about MATLAB, and Oscar Molina will present today's sessions. We also will have about 8 or 9 more sessions in coming weeks. And I would like to ask you here to keep attending our sessions, and at the end of the bootcamp, please give us the feedback, how our sessions have been lined. So I would like to give a special thanks to our sponsors, Geological Surveys of Denmark and Greenland, MathWorks, Oilfield International, Accenture, Microsoft, NVIDIA, CGG, Samsung, TNO, and Terra Alta Maria. And today's speaker is Oscar Molina, Senior Application Engineer from MathWorks. He is a mechanical and petroleum engineer with a strong mathematical background and proven skills in computational fluid dynamics, finite element analysis, and oil and gas reservoir simulation on high-performance computing machines. He has extensive experience on writing performance codes in C++, Python, and Java. He is also proficient in data structures, algorithms, runtime space, complexity analysis, parallel computing, algorithms, and optimization libraries for massively parallelized models. He is also familiar with process and control engineering, feedback systems, and machine learning. Oscar, the floor is yours. We are happy to have you here for this presentation.
Thank you very much, Ahmad. Oh man, that's a mouthful when you were talking about my bio. Yeah, I mean, in a summary, I'm coming from the oil and gas industry. I worked there for about 8 years. In different roles. I work onshore, offshore, internationally. But my last 2 years, I work as a software developer. So I'm very familiar with, writing performance code with C, C++, Python, Java, as well as with MATLAB. So yeah, it's my pleasure to be here. Thank you very much for the invitation. I was really looking forward to this presentation. And also I take advantage of this opportunity to apologize for not having been able to make it last week. Nonetheless, I saw the recording from Neil's presentation, and I'm pretty sure that it was beyond expectations. So I hope that you guys enjoyed that intro to MATLAB presentation, and today is going to be a continuation of it, okay? So the idea here is to take what Neil mentioned about what we can do with MATLAB and Python, and then here we're going to dig a little bit into 3 different ways. That's what we're going to be talking about today, right? So without any further ado, let me just share my screen, and then we can start the presentation right there, okay? Right, give me just 1 second. And also I'm going to knock off my camera because I'm at a hotel room, so I don't know how reliable is the internet connectivity over here, right? Please let me know if you all can see my screen.
Yes, it's perfect. Thank you.
All right, perfect. So let's kick it off then. So today we are, for the purpose of this demo, we are going to build a cryptocurrency forecasting tool. So what we're going to do is we're going to take a MATLAB, a Python function to connect to Coinbase. And then based on that function right here, we are going to retrieve a bunch of data from that particular database. And then we are going to ingest that data into MATLAB, to process the data, clean up the data, and then come up with a machine learning model that will help us predict the cryptocurrency pricing behavior in the future. Okay, so that's essentially what we're going to do for this particular presentation. The idea here really is to show you the 3 different ways in which you can integrate MATLAB and Python. Okay. MATLAB production server, we are, at the end of the presentation, at the end of the demo, we are going to see what are some of the challenges that are associated with enterprise solutions, okay? So this is something that I want you guys to keep in mind because we tend to work on solutions on our desktop machines and think that they are scalable, and we might find ourselves into troubles when scaling up those solutions, especially when we are thinking about cloud solutions or cloud applications. So we are going to briefly touch on that towards the end of the presentation. And then at the end, I'm going to give you guys some key takeaways for you to take advantage of. And particularly, I will be sharing some of the freely available resources from the MathWorks in about this MATLAB with Python topic. We're going to start with, looking at the big picture system architecture. We're going to see where MATLAB fits into it, and then how the existing solutions in the market can also be integrated with MATLAB. Then we jump into calling Python from MATLAB. Then we'll call MATLAB from Python. And at the end, we are going to see how we can package MATLAB algorithms as royalty-free Python libraries, okay? As you all know, Python, as Mil explained last week, MATLAB's been there for decades, and we are very well known as a numerical computing powerhouse, right? MATLAB is that software in which you bring in your data into it, you do your data pre-processing, post-processing, you develop algorithms, and in the end, you want to report your findings, you want to report or share your algorithms. So that workflow is what we call the language of technical computing workflow. And this is very commonplace with MATLAB. When we think about interacting with big databases, MATLAB play really nicely with the market solutions like MongoDB, Hive, SQL, and so forth. So you can easily connect these databases to MATLAB. The same is true for business solutions or BI systems that like some of these might resonate with you. For example, Tableau, Power BI, Apache Spark. Some of these solutions can also get connected with MATLAB very easily, as well as cloud solutions or virtualization solutions such as Dockerization, as well as Microsoft Azure and AWS. All of those things can get connected directly into MATLAB, right? So this is where MATLAB fits at the center of that ecosystem, if you will. However, for the past 5 years or so, Python has also had its own space in this big ecosystem. And again, the purpose of this presentation is to show you how these two environments can play with each other, okay? So, but it's not only about Python. Like MATLAB really can play or interface with other languages like C, C++, .NET, and Java. And all of that is accomplished through a layer of APIs or a layer of system functionalities called the MATLAB engine. So this is, just a collection of functions that you can use to call MATLAB from Python or vice versa, as well as calling MATLAB from C++ or calling C++ from MATLAB and so forth. But for these particular presentations, we will focus on the Python aspect of the MATLAB engine. I already mentioned this briefly. We can integrate MATLAB with Python in 3 different ways. The first way is calling Python from MATLAB and Simulink. I will probably skip the Simulink part for the sake of time, but we're going to see how you can call MATLAB Python from Simulink. The other way is calling MATLAB from Python. So there are a couple of ways we can do this. And in the end, this is kind of my favorite, which is packaging MATLAB applications or algorithms as Python libraries. And these libraries are royalty-free, which means that you can create them with MATLAB, and then they are free for you to share. Like in the end, you have a .py file that you can share with your teammates or your coworkers, and they don't need to have MATLAB license to be able to use those artifacts that you created with MATLAB. As you can see, the first 2 buckets kind of focus on the developers, right? Because we are the people who take care of the algorithms, that they are performant, that they run optimally. But the last bucket is more focused on the end users, because they really don't care much about what are inside of those algorithms. They just need to know how to use those algorithms. They need to know the ins and outs of it, okay? So let's begin with the first piece of the presentation, which is calling Python from MATLAB and Simulink. So I'm gonna jump very quickly into MATLAB right here. Let's see if we can find it somewhere. Right here, right? let me jump into MATLAB very quickly. So as Mil showed you last week, in last week's presentation, this is the MATLAB environment. Here's where you have your apps. This is the command window where you insert your numbers, your calculations, whatever you want to do. It's right here. And I'm going to show you how you can create a very simple. I'm just feeling lazy today, so I'm going to just create a very simple Python string using the str method for those of you familiar with Python. And I'm going to just say hello world, because why not, right? If I do this in Python, Python will recognize that this is a string, right? But if I do this in MATLAB, MATLAB is going to yell at me. It's going to say, hey, I don't know what you're talking about. What is str or stir? I don't know what it is. For us to be able to tell MATLAB, hey, this is something coming from Python. This is a Python object. All that we have to do is to prepend the py dot prefix to whatever function we want to call. So when we do this, MATLAB already readily recognizes that this is a Python string, okay? So you have access of all of the methods that this Python string object has with it, right? Like typically you do like something like s dot and whatever function you want to call, right? For you to be able to see what you have available, you can just simply call the MATLAB built-in function methods, for example, and then you see all of the methods that you have available for this particular string. So, for example, if I wanted to make all of these characters uppercase, I will just say s equals upper s, right? So I'm using the upper method from Python in order to make this happen, right? And what if I wanna convert that string back into a MATLAB string? So for that, I can do something like this, for example, do string s, right? And now I got a MATLAB string. So this is how you can interact with Python directly from the MATLAB command window. Of course, you can also use other libraries, like for example, the math library or NumPy. So it occurs to me that if I wanted to calculate the square number of I don't know, a random double using NumPy. Sorry, I think oh, my bad. I had to do square right here, right? So I'm calling the square root method from NumPy, from Python right here into MATLAB, okay? So I hope that's clear to you guys. And now let's jump into the demo piece of today's presentation, okay? So the first thing, as I said, that we're gonna do for this demo is we are gonna call Python from MATLAB, okay? And to do that, we are gonna use this Python function right here that I'm showing in VS Code. And this function is gonna make calls or RESTful API calls to Coinbase, as I mentioned at the beginning of the presentation. There are several functions associated with this Python library. So we have the get price data, which is the main function we are going to be using to retrieve that information from Coinbase. And as you can see right here, this is or if you think about this, this is like an IT managed type of library, right? Because it has a lot of components of HTTPS and as well as URL requests and so on. There are a couple more functions right here. We have the parse JSON function, which is we convert the JSON data we get from Coinbase into MATLAB arrays, so that it's easier for us to work with that numerical data. And then we have another function which is that tests whether Coinbase server is online. So this is the main function that we're going to use right here. So let me kind of maximize this right here. Right, so the pyenv command right here, this is the first command you want to use when working with Python in MATLAB. The pyenv command is going to tell you what version of Python is MATLAB seeing at the moment. For example, right here, I'm working with Python version 3.9, okay? And it's loaded, so it's ready for me to use, okay? I already showed you guys a little bit of this. Here I'm using the math library from Python to calculate the square root of 4. I'm also using Python to create a list, which is a kind of a complicated data structure there because you can mix whatever you want inside of a list, and as well as a dictionary, which, by the way, the newest version of MATLAB also introduced dictionaries, which are optimized hash maps that are really performant, so you should definitely check them out. Right here, we are going to use the function that I just showed you, data lib, and then from there, from that particular function, we're going to use the get price data in order to retrieve that information from the web. And you saw that it was accomplished seamlessly. You didn't even notice when this happened. And right here, we have the data already. Then we do a little bit of data, kind of like manipulation. We just wanna parse the data into MATLAB in the form of arrays, right? And then you have it right here, the data, and then in the end we can just plot the data, and we can see the plot. We can actually export the plot, or in fact, right here. In fact, we can export the whole live script, which I'm going to show you just in 1 second, right? So yeah, here you can say the plot, copy, do whatever you want. If you want to insert a line just to show kind of a trend, you see a trend right there and so forth. You can do all of that directly from MATLAB. And again, as I just mentioned, if you wanted this to be a report that you want to share with your manager, for example, you just come here to the export icon here in this tooltip, and then you export as a PDF, and then you will get a nice report like similar to what Mil showed you guys in the previous session. Okay. One thing to mention here that I want to make you aware of is that you saw that there is a little bit of data conversion here that happens under the hood, but it's also good that you are all aware of what is happening under the hood, right? Because data type conversion is something that you will be frequently working on or with between MATLAB and Python, because the way that you interpret a double in Python is different. It might be different than the way that you interpret a double with MATLAB. So it's always recommended that you are aware of all of this data type conversion that is happening there. So Mil also pointed this out to you last week. The MATLAB documentation is very rich, so I highly recommend you guys to come in here. And if you want to learn more about how to, about the functionality of MATLAB with Python, you have extensive documentation right here called Python for MATLAB. So many of the things that I'm showing you right here are here in the documentation. And in fact, I will recommend you guys, please try not to memorize the commands that I'm using, rather focus on the workflow and the functionality that I'm using, because in the end you can always come to the documentation and look for what you need, and also you can go and I'm going to show you a couple more resources at the end of the presentation. So MATLAB to Python data type mapping. This is going to tell you all of the one-to-one mapping that happens between the two languages. So how you convert a MATLAB double, whether it's complex or real, as well as integers and so on. Everything is right here in the documentation. Let's not worry about it for the time being. This is something just for you guys to be aware of. Okay. So let me go back to the slide deck. We already talked about this, and here's a link to the help. What are the requirements for us to do this magic between MATLAB and Python? Really, Python, the API for Python was introduced back in 2014. So any MATLAB version starting from 2014B onwards should be good to go. We support up to Python 3.9, as you saw me using here. It says 3.8, but now it works with 3.9 as well. So you can always refer to the documentation to make sure that you are using a supported version of Python. And lastly, this is almost obvious. Just try keep in mind that whenever you use Python and MATLAB, they all have the same architecture, right? So if you're using 64-bit architecture, make sure that you're also using MATLAB 64-bit as well as your operating system, so that everything is consistent. One question that I came across a lot is, do we support pandas? And the short answer is no, we don't support pandas directly. Instead, we support Parquet, which is a highly performant data frame that is readily available both in MATLAB and Python. and it's rather simple to use. So for example, if you are more used to use pandas for your testing in Python, for example, you can create a Parquet data frame from Python and then import that data frame into MATLAB just using the Parquet read command. It's very, very easy. So just bear in mind that this is something that you may want to do if you are using pandas data frames. Data frames in Python, and you want to call them into MATLAB. As I said at the beginning, just in the interest of time, I'm going to skip the Simulink demo. For those of you who are not familiar with Simulink, Simulink is our block simulation environment in which you can, design control systems as well as physical modeling, and all of that is supported by MATLAB. Okay, so Simulink works on top of MATLAB, and there you can also create your blocks that contains Python artifacts right there. Or actually, in fact, just let me quickly show you what this Simulink environment is about. Hopefully, it won't take me very long. So the example that I'm going to show you here, for those of you familiar with control engineering, those who has a background in EE control engineering will pick this up very quickly, hopefully. So what I'm going to show you is a PID control that we are going to see the kind of like a head-to-head comparison between MATLAB and Python. On the Python side, we are going to use a Python object this time, different than the previous file that we used. This one, which is a library which contains some functions. Here we are using an object. It's called a PID object. Okay, so it has its own methods. So this is a little bit on the object-oriented programming side. Just keep in mind that this is just an object that has its own methods and it's all encapsulated. So in a way, it's the same as a library, but it's kind of self-contained. Just let me put it that way. So right here, I have a very simple PID control system with a plant model. This is what the Simulink environment looks like, and everything here is block-based. So essentially, you are connecting blocks in order to build your simulation models. So let me just run this just to show you what's going on here. Right here, where you see the PID class, this is when we are importing the Python artifact, and we are telling MATLAB Simulink, hey, this artifact is coming from Python. So here we define the file where this is coming from. We are telling Simulink, hey, don't worry about this file. Do not try to convert this into C code, because by the way, everything that you run here on Simulink is converted down to C code for it to be highly performant. So we're telling Simulink, do not bother about it. This is something different. So just use it as is, okay? And then we create a Python object, and that's the result. So you can see, as you can see here, there's not much of a difference between the two. But just in case if you're working with control systems, I highly recommend you to stick with Simulink to do your PID controls. Simulink is very good at it. You can, you do auto tuning. You have plenty of options right here to play with your PID, and whereas you might be a little bit limited with the Python object. Yeah. So this is a quick view of Simulink and how you can also import Simulink or Python artifacts into Simulink. Okay. All right. So let me go back to the presentation mode right here. Now let's move into the second part of this talk, which is calling MATLAB from Python. So we're switching gears and we are going to move into the Python environment. I'm going to show you how this process takes place. At the beginning of the presentation, we saw that all of this can be accomplished. What I mean by that is the connectivity between MATLAB and Python can be accomplished via the MATLAB Engine API, right? And the MATLAB Engine API, what it does is it creates two client processes, okay? So the first process is the client process, and the other process is the server process. So the client process is where all of the algorithms are running, and the server process is going to be MATLAB for this case, okay? So let's assume that you have a Python code and you are calling some MATLAB functions from there. So those function calls go into the MATLAB engine API, which process the calls, and then it puts them in a way that MATLAB can understand, right? And then once the results are returned, MATLAB takes those results back into the MATLAB engine API, which converts them back into a Python language that Python can interpret. So this is essentially how the connectivity happens under the hood. Here I'm going to demonstrate how it happens. So I created a Python environment. So the next thing I do is I import the MATLAB engine, right? Which is what we just saw. And then I initialize that engine. I start that engine, which in a sense, what it's doing is it's launching a MATLAB session in the background. You are not seeing it right there because it's happening in the background. So it's going to be ready for you to use once it's fully loaded up. So it typically takes, 10 to 15 seconds, however it takes to load up MATLAB. Now you can use MATLAB the same way that we use Python, and the example that I showed you about NumPy or the math library is the same thing right here from Python, right? So I'm calling the linspace function, for example. I can also call the power function to operate on X, which is a MATLAB artifact, all directly from Python. And lastly, I'm going to show you, like, I can plot these results. And what you are going to see is going to be very familiar because it's just a MATLAB figure right here, right? So this feels and looks like you are working with MATLAB, except that, the command window is not white, but it's dark. But other than that, and plus you have to call MATLAB through the MATLAB engine. But other than that, is the same as if you were working in a MATLAB environment. So the connectivity there is very seamless. So this is purportedly done for you guys to be able to use MATLAB and Python in a way that, you can choose the environment that you like and then work with both of them from there. So with the MATLAB engine, you can create and terminate MATLAB sessions. In the previous example, we just created one session, but we did not see the MATLAB window at all. There was just a MATLAB session running in the background. But in the next example, I'm going to show you how you can actually pop up a MATLAB window that you can use for debugging purposes, for example. So you can move data around. You can move data from MATLAB into Python and vice versa, and take advantage of MATLAB powerful, capabilities to create new algorithms, machine learning, and so forth. You can also call MATLAB commands synchronously or asynchronously. And this is something great because, for example, if you have a very large data set that you want to process with MATLAB, but still be able to continue working on Python, you can call the MATLAB engine asynchronously and just assign that job to that engine and tell it, hey, process this billion data points and give me a result back whenever you're done. And then MATLAB will take that the task, will perform it, while you are also free to continue working on Python. So this is a really huge advantage of the MATLAB engine. And of course, the data typing that I just showed you a minute ago, it happens implicitly when you are calling the MATLAB functions from the Python environment. Okay, so let me jump right ahead into MATLAB very quickly over here, and let's take a look into that part of the demo right here. So we're going to go back, just to keep you guys in track. We're going to go back to the cryptocurrency prediction, right? Let me just quickly show you what we did prior to using the MATLAB function in Python. I just want to make you guys aware of what happened here. So we got some data. This is the first example that I showed you. We retrieve data from Coinbase, and then we save that data in MATLAB, and we use that data to train a machine learning model. The way we did this, and not to go too deep into the details, again, for the sake of time, I'm just going to briefly touch on this. So we created a data set in which we use a moving average to kind of clean up the data, fill up for missing data points there. And you see that right here, we have a collection of data. Excuse me, have a collection of data right here. And then here we created testing and training data sets, and we use the regression learner app in order to create the machine learning model. Once the model is created, as is shown here in this figure, once the model is created, by the way, the regression learner app is right here. So if you look at the statistical toolbox, or you can just do right here, machine learning and deep learning, you have the regression learner right here. Once you get the model from regression learning, you can just save it. Here we save it as cryptomodel.mat. And here we train the model. We call the function predict price. And you can see here the comparison between the historical price and the predicted price. So it's a very good result. And this is how the machine learning model compares to the historical pricing. So it's very close, right? And this is the function that we are going to be calling from Python. Okay, so let me just hit this link right here. Here we have the Python script in which we will instantiate MATLAB through the MATLAB engine right here. So you see that I'm importing the MATLAB engine, then I'm initializing the MATLAB engine. But one thing to note though is that I'm using this qualifier inside of parentheses, which is just telling Python that whatever MATLAB session you create, please open up a desktop window. So here you see that I'm launching a brand new MATLAB session. It's initializing right here, and it's just looking through the project. It's setting everything up for me to be able to use the MATLAB artifacts. So right here, we are importing the MATLAB engine, initializing the session, and then we continue on through the MATLAB through the Python script. So right here, it initialized the session. As you can see there, let's go back to Python. So it's loading the crypto project. And here it's loading, just 1 second. And then it runs some function right here, right? So it's using the predict price function that I just showed you guys to make some predictions for a particular cryptocurrency. In this case, I believe is BTC, is Bitcoin right here, but you could have chosen the other ones that are available right there. So you get the results here, and in the end, right, we have the final results, but the MATLAB session is still open, right? And we can see right here in the workspace the data that we use to make those calculations, and this data is available for you to use. So, for example, if I wanted to open this coin price and I wanted to plot it, I can just choose this plot right here, and I see the data that I just work with, right? So I can go ahead and modify the plot or use this data, do cleanup, do more than analytics if I wanted to. And once I'm done with it, then I can quit the MATLAB engine as I'm showing right here. So if I just hit a key, the MATLAB session is gone. So I'm back to the one session that I've been using so far. Okay, so it's very straightforward. You saw how easy it was to call MATLAB from Python. For the last part of the demo is about how to package those artifacts that we just saw, right, in MATLAB. So we had to go to MATLAB, take a look at the functions, and then use them in Python. And the question here that we want to address is there a way that we can package them into a Python library that I can later use in Python without having to worry about MATLAB? And the answer is yes. So we can do this through what we call the MATLAB compiler SDK. What the MATLAB compiler SDK does is it takes your MATLAB applications or artifacts or algorithms, whatever you have in MATLAB, and convert them into a .py library, which you can, in the end, use directly from Python. So the end user will be able to just grab your Python library and use it. And for this, we need to use the MATLAB runtime. MATLAB runtime is a collection of libraries that is freely available online. You can go ahead and download it. And I'm gonna also show you how MATLAB can create that installer for you automatically. And this is where MATLAB is, is gonna process your information, right? Because now we do not depend on the main MATLAB application, but this is independent of MATLAB. So all of the function calls will be made against or will be run against the MATLAB runtime, right? So for this, we use what we call the MATLAB compiler SDK. So let me jump right here into MATLAB and show you guys how we can do this there, okay? So right here we have, let me go back to library compiler. Right here we have the library compiler, the compiler SDK. So if you're curious about it, you can go, here's where you find it in MATLAB. So you go down here in your apps menu and application deployment, you have library compiler, or you can just simply type library at the top search bar, and then you'll find it right there. So what you do here is you add the functions, the MATLAB functions that you want to use, right? So you can simply add as many of the MATLAB functions as you want right here, and you give it a name. You make put some description down here, and MATLAB will automatically catch up all of the dependencies for you. So you don't have to think about, hey, which dependency is which. And this is particularly useful for some of you like myself who are coming from a C++ background, for example, that dependencies can be a headache, like including the headers, the include folders, and so forth. That could be really, really cumbersome, but MATLAB takes care of all of it for you automatically. And not only you have the option to package Python artifact or library, but also you can create a DLL, a C-based DLL or C++-based DLL, the C++-based DLL, as well as Excel's add-ins, as well as .NET assemblies. So right here, once you're done, you're gonna hit the package button right there. What MATLAB is going to do is it's gonna call a compiler, and it's gonna make your MATLAB, it's gonna encrypt and compile your MATLAB functionality, which is something to keep in mind, okay? So whenever you have your open source code in MATLAB, your IP is protected when you compile this in the form of a Python library. So you don't have to worry about IP protection because the data is already encrypted. So you are sharing your libraries, but not your IP. So it usually takes a couple of minutes. It really depends on your machine for the compilation process to get done. Once it's done, MATLAB will automatically open up the resulting folder or the output folder, in which you can see 3 different folders. In the first folder for redistribution, you'll find an installer. You can name it however you like right here, and this will install the MATLAB runtime library for the end user. So they just come here, open up this executable, and the MATLAB runtime gets installed. You also have this packaging log HTML. If you open it up, it will just show you what compiler SDK did in order to compile your function. And then you have this for the redistribution files on the folder, in which you have your crypto class library with some sample file, and then you have the getting started instructions. So MATLAB is already telling you how to use your own library, right? So this is very useful because right here is where you install your library for Python to be able to see it and use it. And then you have a sample Python file that you can use to test the validity of your library, okay? So this is very straightforward. As you can see, now with this folder that I just showed you, you are free to share with your coworkers. So if we want to see what the difference is between calling MATLAB from Python with the MATLAB engine and now calling a library that you created, we can compare the 2 files right here. So main differences are in this section where, if you recall, we imported the MATLAB engine and we initialized the MATLAB engine, and we also told Python, hey, I want to see the MATLAB section on my screen. So we did it right here. But here is different because we just import MATLAB and then we import the library that we just created. It can be called MATLAB library or cryptolib, depending on the name that you chose for the library. And then other than that, here you start your MATLAB environment. Here you start your MATLAB environment. Here you initialize your library. You use the library, same functionality, same procedure, and in the end, you terminate your library. So you make sure that the MATLAB runtime is properly shut down, so you don't misuse your memory. So this is all about using your function from your Python library directly from Python. Okay. So now let's go into enterprise challenges. So far, we saw that the workflow is rather straightforward. It's very easy to use. It's very easy to follow. However, there are some challenges when we think about scalability, right? Everything that we've done is on the desktop, is really desktop-based. For testing purposes, is okay. But what about when you are in an integrated development team, where you have many things moving around at the same time? There are requirements coming from all different, from all the places, and then you have to take care of them. How do you respond to, changes in requirements and as well as new requirements? Now, maintaining the version of your Python libraries can also become a little bit challenging, especially in response to the new requirements or to changes that you made. How do you make sure that the library is updated or gets updated for everybody? How do you centralize your analytics? Also, how do you support multiple use cases? And in fact, how do you support multiple users using the same library and make sure that your library is robust enough to be, to not break up or break down with different use cases? So that's something to keep in mind when thinking about scalability. And of course, getting your models into the hands of decision makers faster. Decision makers don't care much about the algorithms or how fast is your algorithms, but rather they care about the business case. So how do you quickly build up something to prove your case? So how do you build something quickly in order to prove the value, the market value of the solution that you have in mind? That can become a challenge when you think about scalability. So the ideal solution here is something that that requires the least possible data transfer, right? So here you're thinking about centralizing not only your analytics but also your data, that all of your users can see the same data, can access the same data, and can access the same algorithms from a centralized, central computer, if you will, right, from a central platform. The ideal solution also would support multiple interfaces. So not only a given Python environment, but different environments, MATLAB, different versions, and so forth. And also your ideal solution should be scalable and flexible. So if you think about using these artifacts that we just saw in both MATLAB and Python, and if you're thinking about, oh, how can I take this into AWS, for example, where I have a large data set? How can I take this to Microsoft Azure, where I have already a backend in place and I want to incorporate some pieces of what I just saw. So this is when we think about scalability. So for this particular presentation, we saw how MATLAB and Python can interact, how they integrate through the MATLAB engine. But really, we can integrate MATLAB with other code. And what I mean by that is that at the beginning, I showed you guys that the MATLAB engine also supports C, C++, C#, and so forth. So here, MATLAB becomes kind of your workhorse for algorithm development, because not only you are appealing to your Python coworkers or those coworkers that are using Python as the main development environment, but also others that are using C++. And in fact, we have had some customers here that I have supported that some part of their teams work with Python, another part of the team are working with C++. And then we are using MATLAB as that centralized analytics platform in which they can interact and talk to one another using the algorithms and artifacts that they develop separately. So now the idea is to take that principle, that core functionality, to the cloud, and this is where MATLAB Production Server comes into play. So MATLAB Production Server, what it does is it allows you to deploy all of your libraries and algorithms directly into the cloud. We have a dedicated website for MATLAB production server. I can give you guys that resource at the end of the presentation. And there are, already well-defined reference architectures. So if you are working with AWS, for example, we have a reference architectures for it. So you can go to the MATLAB, to the AWS marketplace and just look for MATLAB production server, and you will see it right there. The same is true for those of you who are working with Microsoft Azure and even with Docker. So we have all of those solutions pre-built for you guys to use. Right. So if we think about it, we can just come back to compiler SDK. Compiler SDK is wonderful because it has so many possibilities when it comes to deployment and deploying your artifacts. So right here we can create a MATLAB production server. This is what we call an archive that contains several MATLAB functions, right? Like these ones, for example. So I'm gonna add them up right here. Compiler SDK, as I mentioned at the beginning, is gonna look for it's gonna catch all of the dependencies automatically right here. So there's one more file that we need to add manually, which is the datalib.py. So once we have this ready, we can just simply do whatever we did for the previous example where we package the Python library. We can just hit package and then take that CTF file right here and deploy it to MATLAB production server. But we can also test this on our local machine, right? So when we hit the test button and then we enable this server, we are mimicking what MATLAB production server is going to see in your web application, in your cloud, right? So if I run this and I go back to production server right here, you see that I made a call, a RESTful API call to that server, and here I'm using a web environment in order to make that RESTful API call, and here I got the results. Okay, and also I can go to Python, and hopefully this will work. Double check this one. But you do the same. You create an HTTP client, and then you make a RESTful API call to your server, and then you get the results right here. And if you look at again at the MATLAB production server window, you see that you had some calls coming in, and the calls were correctly processed. So this is the way that you can easily test your archives, your production server archives, before you deploy them. This is a nice way also to test that your archive will work with both web interface, and if you have Power BI, that Power BI will make the adequate RESTful API call to get these results back to you. You can also use Postman, for example, or any other ways to make API calls to your functions. And as you can see, you will get the same results consistent. Okay. All right. So as a summary, we saw how to call Python from MATLAB and a little bit of Simulink. I kind of went through fast over there just for in the interest of time again. But I hope that I gave you guys an idea that you can call Python from the MATLAB environment. We also saw how to call MATLAB analytics from Python, and we took a look at the MATLAB engine, as well as creating a Python library based on the MATLAB functions and algorithms that you had created previously, and use compiler SDK to create that library. And lastly, we saw a little bit of why this can become a challenge when you think about scalability, and how MATLAB production server can help you deploy your artifacts directly to the cloud using one of the reference architectures there. And then you will be able to make calls to your MATLAB algorithms from different environments, just from whatever can make a RESTful API call. So there are, I'm pretty sure you saw many benefits of using MATLAB with Python. I just want to highlight some of them. Like one of them is integrated workflows, right? So now you can collaborate with other team members that aren't necessarily working with MATLAB or Python, but with all programming languages, right? So with that, you can effectively enhance the existing MATLAB functionality and then increase value in other programming languages by using built-in MATLAB functions. Okay, you can quickly prototype and deploy programs that you can show to your upper management and prove value, and prove a business case and so forth. And lastly, you can easily pipe data between different IT systems. We just saw that you are able to effectively centralize your data and algorithms, and many users will be able to to use those from different environments, and many more. Of course, you will get to discover that when it comes to machine learning and deep learning and working with pre-existing networks, MATLAB can definitely make your life easier with connecting those networks with Python. There are some resources for you that are available for you to use. These are free resources. I highly encourage you guys to go and take a look into them. There is plenty of information right here. These websites are really useful. Even myself, as a MathWorks employee, I very frequently refer to these websites and grab some information from here. So I highly encourage you guys to take a look into that. There are webinars, plenty of information, again, freely available for you to use. I showed you those free resources. And last but not least, we have the cheat sheets. Very useful. I think Neil brought them up during last week's presentation or last session's presentation. I definitely encourage you guys to take also, go and grab them. They are available on our website in the form of PDF documents. So take advantage of those as well. And of course, videos and webinars, there are plenty in our MATLAB website. For those of you who are not very familiar with MATLAB or are starting the journey to learn MATLAB, I highly recommend the MATLAB Fundamentals course training. So when I, when I joined the MathWorks, I'm like, oh yeah, I'm very good at MATLAB, so I don't need any training on it. But it turns out that when I took this training, oh my God, I personally found so many things, so many tricks that I completely ignored before. It will make you more productive. It will make your interaction with MATLAB more friendly. So I definitely, in fact, I highly encourage you to consider enrolling in one of these courses that are offered year-round. One last thing I wanted to mention: when you think about why MATLAB, there is one thing I wanna bring up to you guys. So whenever you encounter a problem with MATLAB, whenever your algorithm crashes, it will send us a report, and then we will take a look into what happened and try to help you out with that. Okay, so there's while you have like websites or forums like Stack Overflow, when you're using Python, you're trying to figure out what happened with your code or how can you improve your code. You can also have access to our technical support. So we are here to help you guys succeed when using MATLAB with Python. So please keep that in mind. With that, I want to thank you all for joining this presentation. It was, again, my pleasure to be able to communicate all of the value that the integration between MATLAB and Python can bring to you, especially for this hackathon, which, by the way, I wish you all good luck with the hackathon. Thank you very much for your attention.